of your service deployments are. The term here called as VIP swap, where we are just going to look into what that VIP swap means. But just to set the context, these are the stages of service deployment. You start with your local development fabric, that is Azure emulator. Everything is on your local emulator. You start developing application. The next stage is to connect to your Azure data services and see it running on local emulator. Then third one is to deploy it to staging and see how it works. If everything is all right, you just upgrade it to the production. So easy to do all this kind of thing in a Windows Azure platform. Earlier, if you think about on-premise environment, it was very difficult to just swap these environments. Moving on. An important concept, having said the context about how do you deploy services and what are the roles and instances, we'll see how do we upgrade your application. So in Windows Azure, we have two options when we upgrade an application. Upgrade means your application is already running and you just want to either change a few things or you have to just deploy some new version of your application. That is upgrade of your application. The very first thing which we talked about earlier, VIP swap, where you have two environments given by Windows Azure, one is staging and one is production environment. So generally we deploy our applications to staging environment and then we swap it, and that is called as a VIP swap. It is in place swap. And Windows Azure Fabric controller will take care of just changing the endpoints and adding everything into the load balancer. Second one is in-place upgrade. It performs a rolling upgrade on live services. It is possible that you have a production service running with multiple instances of your roles, web role or worker role. You want to upgrade it without actually going through this staging and swapping the production and staging environments. You can do that using upgrading it and using this in-place upgrade, where you have two options. One is manual, where you select what are the roles you want to upgrade one by one, and automatic, which is done by Windows Azure Fabric itself to upgrade the roles. The very important point here is, depending on your number of role instances and the upgrade and fault domains, your service is not going down anytime when you upgrade it. That is the beauty of Windows Azure, or any cloud platform for that matter. And very close concepts to upgrading services called as fault and upgrade domains. So fault domains are, they represent groups of resources anticipated to fail together. So what it means by that is, same rack and same server. This is one unit of your fault domain. And Azure, whenever we deploy our application, Azure Fabric spreads instances across multiple fault domains, and defaults are 2. What it means is, when I deploy my web role and worker role with 2 instances, so I'll have 2 fault domains, minimum 2 fault domains. So that whenever one, it's a rare possibility, but if there is a one fault domain goes down, still you have your application readily available. And by the time, in a minute, your next fault domain will come up automatically. That has been taken care by Windows Azure Fabric controller. Upgrade domains, it represents a group of resources that will be upgraded together, and that is where, like, it is specified by a setting in your service definition file. When you develop a Windows Azure application, setting is called as upgrade domain count, and by default it is 5. You can change it. So when I say I have 2 upgrade domains, so when I'm actually upgrading my application, so I'm getting one upgrade domain down, and then it will just install my new version on it, and then second one will be down, and those kind of things. We'll see that in with animated PPT here. Fabric, when I say Fabric, it is Windows Azure Fabric, splits upgrade domains across fault domains and across roles, and that is the beauty. That is where we are getting that high availability, and our service is always up and running, because the Fabric is splitting our upgrade domains across multiple fault domains. So whenever I'm upgrading, it is actually one fault domain getting down, upgrading my service, and coming to the next one. Let us see one example of for upgrade. So I have web role, worker role. I have 4 instances each of both of them, and I see here. So the fault and upgrade domains, just visualize it like this. So you have a rack in Windows Azure Data Center. So the one rack will have web role, which will have 2 VMs. In the worker role, again 2 VM, and another web role, like we had said that web role has 4 instances. What it means is 4 VMs, virtual machines, and worker role also has 4 instances. What it means is 4 virtual machines. So this one rack and one server constitutes one fault domain. So by default, I have at least 2 fault domains. And I have one upgrade domain constitutes of 1 VM web role, set of two VM role in one upgrade domain and set of two virtual machines of worker role in one set of domain. You can see that. So at least I have two fault domains and two upgrade domains in this scenario, in this specific case which we are talking about. How does it help? It helps us to keep the separation of fault and upgrade, so that whenever we are upgrading or whenever there is any infrastructural problem, your service is always up and running. VIP swap. This just swaps the virtual IPs between two slots, and this is generally available for staging and production. We have seen that in the lifecycle development of Windows Azure application. It allows us to quickly swap environment so that you don't have to actually do redeploy your application, and that will be taken care by Azure Fabric Controller itself. It is quick and it is available all the time when we just swap it. It does not occur in any downtime, and we can do that by using our developer portal, which we have seen management portal for Windows Azure. We can do that with a command shell PowerScript running on your environment using service management APIs. One specific tip which we want to provide here is, for the best user experience, invest in warming up the same number of instances in staging before swapping into the production. So the idea here is first you deploy the same number of instances where you are running in production environment on your staging. Start that service running and then swap it, so that you don't have to actually wait for those instances to come up and additional instances to come up which were running in the production. And that will make your life easier, and it is very quick to swap without any downtime. Let us see how it works. So VIP swap upgrade. So you have a load balancer on the left hand side, which is a production instance, for example, and we have deployed our two instances each of web role and worker role. So I have another deployment which is again same domains. So when I say I just swap the production to staging, if you see the endpoints, the color I'm showing here is a production is actually pointing to this one now. In place upgrade, this performs a rolling upgrade on live services, and it takes advantage of upgrade domains. And this can be done again through your development portal, management portal, and your service management APIs. We'll see the example of this. Very specific thing, Windows Azure also uses this upgrade and fault domains for operating system related patches. So it never brings down all the system together. It brings down one at a time, so that your service is up and running. It patches it, and it is readily available for the next use with the next version. One important point when we are developing for when we are taking care in our upgrades, automatic or manual upgrades, at times, very short span of time, but at times your service will actually be running with two different versions. For example, your version 1.0 of an application is already running. You want to take a new version called as 2.0. So when the upgrade is happening, for some of the VM, the version 2.0 would be running, and for some of the VMs, it would be 1.0. It is very short span of time, but it is suggested to take care of that in your code, just to check that versions. And probably if you want to do, when you are upgrading to version 2.0, you might just want to not handle that request for version 1.0, and that is the important tip. For a specific time window, we have to handle that, and we should be having our version aware code. Let's see how in-place upgrade works. Now I have a production environment, and I have two racks which we can call as two different fault domains, where my web role has 4 instances of VM and worker role has again 4 instances. So here we say that there's a one set of upgrade domain which is there in web role, which constitutes 2 VM, and worker role you consider 2 different VMs. So now if you think here, the image has changed. It means it is down now. So set of 2 web role virtual machines are down, and 2 VM virtual machines of worker role are down, and they are actually going to upgrade. But rest of the time you have 2 virtual machines still running for your web role and 2 for worker role. So your application is not down. You upgrade to the new version. I change the image so that you can see that it's a new version now, and now next time when I upgrade, I go to the next set of VMs, and like that at the end of this upgrade, I get everything running onto my new version. So having said, having looked into fault domains and upgrade domains, and our upgrade is very important concept when we think about deployment and upgrading our applications. Let's move on to specific topic with respect to role programming models. So we have multiple events, multiple methods and events available in our web role and worker role. So to begin with, we have an onStart method, which is always called by the Fabric, Windows Azure Fabric, to start our web role or worker role for that matter. It does all the initializing tasks here, and it reports the status to the load balancer where it is like ready or not. Once it is ready, it actually adds into load balancer, and that web role or worker role is available for usage. A run method, this is very important in terms of its main logic for mostly worker roles, but you can make use of this logic in your web role also. It is always running, and you can do all the infinite loops or any specific task which you want to run all the time. You can do you can write that code in the run method of your role entry point, that is web role or worker role. You should never exit out of this. The moment you exit, it is actually going to recycle your role. OnStop method, it is called when the role is going to be shut down, and it is actually graceful exit. I mean, it is not going to get shut down immediately. It gives some around 30 seconds where we can do some specific on-stop activities when your role is going to stop. Let us look at the role life cycle here. So we saw the deployment life cycle. Now let's see about what happens when we start a role. So all roles extend from role entry point. There is a class which is being used by Windows Azure. We are going to see that in the code again. Roles report status via role environment. There is another static class which we have, and it is being reported back to the Azure Fabric controller. And depending on that status, Azure Fabric controller takes appropriate actions. For example, if your role is busy for too long, if it is down, it will start spinning up a new virtual machine for your roles. Let us see how it works. So you have the Fabric calls a method called as onStart, just to try to initialize your roles and make sure that it runs. It keeps checking the status. There is an event for us, status check, and when the status, generally when it starts starting up, the status is busy. So the moment you get status as ready, your run method is called from the Fabric calls, so that whatever infinite loop you have, it's keep running all the time. And your actual requests are routed back to your service from the endpoint. When the onStop, when by any chance if you are stopping your service or if there is a problem in virtual machine, it is actually going to call this onStop method. And the status, when it is calling this onStop, the status will actually go back to busy, so that it is not available for the external users to make use of that virtual machine. So that is the basic role environment cycle which we have: onStart, run, and onStop. These are the methods provided by role entry point class, which is being used for all the roles available in our Windows Azure. We have another event called as stopping, and which occurs before actually stopping, before calling the onStop method altogether, and that is where we can write code to handle and graceful exit of our virtual machine. Apart from looking at those methods, there are a few events which I want to specifically talk about, and just to make it short, I kept some code blocks here. Now, one event, stopping, where how do you assign that event is like using RoleEnvironment.stopping. That is an event exposed by the role environment, and you can capture that event using this stopping event. Whatever you want to do in graceful exit of your role instance stopped, you can write that code in here in this event. Status check, another interesting point, like another event which Windows Azure Fabric Controller or role entry point is giving us is status check. We can add a hook to it and trap that status check event. Very specific example I just want to throw out here is, in some cases, if you want that your virtual machine should be running, but it should not be available outside in your load balancer. In those cases, you can explicitly set the busy status to true using that status check event arguments E to set busy, so that it is not available to the load balancer for some time, and the request will not come to your web or worker role for that matter. In some of the cases, you might want to do that when you are developing complex applications, and this is the place to use that status check. When we change configuration values in Windows Azure, we saw that whenever we change that, our web roles, our worker roles, or virtual machines are never down. The change which I make, it is actually slowly, gracefully passed on to our virtual machines. How does it do that? I mean, if I want to do specific task in when when somebody is changing the configuration, these are the events which are available to us. So role environment dot changing, it occurs before configuration is changed. So for example, if I have a connection string, data connection string, which is pointing to my Windows Azure storage, I want to change it. So the moment you change it, Fabric controller is going to call this event on your role environment called as role environment dot changing, and that's where you can take care of if you want to restart that virtual machine, or you are okay with not restarting and just using the new setting in your application. And if you want to recycle that, you can actually set that to cancel equals to true, and it will restart that virtual machine and take the next settings once it restarts. Change event occurs after everything, like all the config changes has been applied to all the virtual machines. So there is a parameter which we can make use of, role environment configuration setting change. That is where we get all the values what has changed in that configuration value. So there are two things. One is a configuration setting change and one is a topology change. So configuration settings means your application settings related values which you change, and topology change would mean mostly the role counts. Like for example, as of now I have 2 instances running, and if I make 4 instances, or from 2 to 1, so it is actually going to change my topology of my application, and that is where we can make use of these collections, role environment topology change. We'll see the example how do you do that in our code. So we have this changing and changed event code again, so I just wanted to put it here so that we understand what it does. If you see in this example here, so I'm in on start, I am just adding a hook to the changing event, and then I get this event here. And here I can, using this changing event arguments, I can change what has changed. So I'm saying if anything changes, and if that change is configuration setting change, I want to restart my virtual machine, because everywhere in my code I have cached that configuration setting, and that is why I want to restart it. If you don't put it e.cancel equals to true, it will not restart the VM, and it will just slowly go to the changed event and it will apply all the change settings to it. Now another point, local storage, which we introduced initially. So this is specifically, as we said, role instances has their own virtual machine. So virtual machine should have some disk storage available to us, right? And that is where the local storage is. So every role instances has its available disk storage. We can use local storage element in the service definition file to mention that we need this local storage, and we can actually mention that what is the name of that local storage and what is the size of it. There are 3 attributes to it. Name, how you want to access that local storage, and if you want to clean on role recycle. It is possible that when you are actually recycling your own role, it is highly possible you're going to get the same virtual machine because we have recycled that intentionally. So do you want to keep those values or those files which you have created on local storage, and that is the parameter which you can mention here, clean on role recycle. If you say true, it is going to clean it. If false, it is not. It is going to keep the files there itself. And you can also mention the size of how big that local storage should be. You can create multiple local storage for that. We'll see that in the demo how do we create local storage and how do we access it. It is persistent, but it is not guaranteed to be durable. Yeah, because it is part of that virtual machine, and if I'm recycling or if my virtual machine is going down, I might get a new instance altogether. So all the files, all the values which I have stored in my local storage might get lost because I'm going to get completely new VM. And that is why it is good for cached resources or temporary files which are not very durable, which we don't want to be durable. For durable storage, for durable files, we have options like, you can make use of blobs, and you can also make use of storage drive, that is Windows Azure drive, which is as good as your local storage like D:, X:, whatever you want to access it through. You mount it as a drive, and that is durable, accessible across multiple VMs. So even if your VM is down, you're actually whatever you wrote on that local storage or that drive is stored in the blob. So it is highly available, it is durable across virtual machines. That is local storage. How do you define that in your service definition file? So there is a config setting for local resources, and you can just say local storage name of my local resource, size in MB, and clean on recycle. How do you use that in the code? RoleEnvironment.getLocalResource, give the name of your local storage name which you have given, and the root path. It is going to give me the root path where it is going to create. So it is abstracted from us. And then you can just go through the directory info, and you can just do normal system.io operations which we have been doing on our directories. We'll see an example once we run the demo for Windows Azure. with respect to configuration values, so there are two ways. One is you define your configuration values in service definition, and then you have those names of the configuration values, configuration settings in your service definition file, and then you put values in your configuration file. Don't use web.config for values which you wish to change, at runtime. So that is the beauty of service configuration file. So what happens is web.config file is part of your package and you don't have access to it once it is deployed. You might want to change a value in web.config on a package and redeploy it. But in service configuration, it is available there. You can just make change on it and it is not going to redeploy the application. That is where we saw this role environment events, right? Changed event, where service configuration might change and it can actually just respond and be there as it is without actually taking down that VM. So the tip is you want to use service configuration for the values which you wish to change at the runtime and not the web.config. Now startup tasks. What are the startup tasks? So they are actually introduced in Windows Azure SDK 1.3. They are commands which are executed before your role is started. They are generally scripts, like you can say batch files, command files, or some kind of scripts or executables which you want to do. This adds lots of flexibility to Windows Azure. I mean, take some example. Before your application, when you are running a web role, you need to set up few things in IIS, some custom settings. You can do that through startup task. If your web application needs few custom components or some installers to be run on that virtual machine before you start your web role, startup task is the way to go out. So these tasks are executed before the role is getting started. Why do we need startup tasks? As I said, sometimes setup is required before execution at the top of the code. At the top of the code isn't good enough. I mean, so we need few DLLs, few assemblies, or few installer to run before actually we consume them in our role. And we do not have complete control of VM, right? And that is where we make use of this startup tasks. We have multiple types of startup tasks. One of them is elevated and non-elevated. So elevated startup task has administrator access. So all the registry settings and other things which we want to do, we can do through this. For installing some few specific things and making use of that in Windows Azure platform, you might use a VSD like VM role, but that would be overkill. I mean, you might have to set up everything on your local desktop first, create that VSD and try to upload it. If there is a change, again you do the same thing. But here, that using startup task, you can avoid that. You can just run some of the MSI files, and you can execute some assemblies using the startup task. We are going to see one example where how do I install my COM component, PB6 COM component on Windows Azure machines, Windows Azure virtual machine as a startup task, so that it is all the time available whenever the role starts. So there are multiple options. You define the startup task in service definition file. You can say I need elevated access or not. You can set and use of environment variables. If there are some of the startup tasks which might need some environment variables. For example, if you want to install some third-party component, they might look for some environment variables already. So you can set it up in your definition of startup task and make use of them in the startup tasks. There are three modes available. One is simple. Most of the time I use simple, which is like by default. If you don't mention it is simple. It is synchronous. So first it executes all the startup tasks, and then it will go to the role lifecycle. So it is synchronous. In asynchronous, we have two options: foreground and background. Foreground, it blocks the shutdown. If there is something wrong with your VM, it is not going to get shut down unless the foreground tasks are completed. In case of background, they don't block the shutdown. So if there is something wrong with the VM and it is going down, you can actually background processes, the background startup task do not interrupt the shutting down of that VM. So the best practice, generally we use simple because that is what we want. We want to install all our assemblies, all our third-party components before the role starts, and that is where we make use of simple. We'll see demo of it in the code once we see once we go to the Visual Studio. Few tips, as we said, startup tasks are generally scripts, and I generally use batch files or command files to run my startup tasks. So log everything. So all the commands you can redirect to your any text files, output of that to the text file, and you can also output your errors to another text file. So these are the DOS commands specifically. You can redirect to the text file. R2 is like for errors. Use override like /y as a parameter in everything wherever you are using any startup tasks like batch commands. So it will not wait for any input from you. Y stands for passing the yes parameter to your DOS commands. You can make use of local storage, which is because for that specific instance of VM, when it is starting, you already have that space available for you. Reboots are fine if you need to reboot your virtual machine after installing something. Like there are few installers which we have used in Windows Azure which needs restart of the VM. That is okay. So because it restarts, it comes back again and start taking the same events. But don't even go to any infinite loop, because if you go to the infinite loop, your status of the role will always be like ready, busy, initialize, and all those kind of things, and it is not available to the end user, and it will always go in the infinite loop. You are wasting your money and time on setting up the VM. You can just use of this command to check the local system also, and while using the batch files, generally we suggest using exit/b0 just to come out of that batch file rather than using some EOF kind of commands in our DOS file. So these are basically some few tips which we need to be implemented in our batch files to make best use of the startup tasks. When not to use startup tasks? I mean, if there are long manual fragile installations, as we said, if we need to install something like, imagine Oracle, if you want to install Oracle, I mean, probably startup task is not the best way to do that, because it's a completely new software. It is going to take a lot of time. It is very fragile. So it's for those kind of things, it's better to use VM, create your VM locally, install Oracle on that, and then upload it to Azure and make use of it. I mean, that is one example which I could think about. There could be lots of things like any custom softwares which needs long and manual interaction with your installation procedure that can be done through this. Okay. Things that require IIS pool to exist already. I mean, you don't use a startup task for that, because the role instance, when it is starting, the IIS pool is not ready, and you should not assume that when you are writing your startup tasks. If you are writing some processes which needs to be monitored for most of the part, do not use startup task for that. The easier way is to execute that process from your web role or worker role using process.start and wait for it exists. That is how you can monitor that. Not really. We don't really need startup task for that. There's another option underneath your service definition file, runtime section. We have a program entry point. You can just set up an exe there, and it keeps running all the time. We'll see that also in our demo. So after talking about startup task, as we said, role entry point. So we have custom role entry points for that. You can run any executable in your code, and it is not limited to .NET code. You can write any executable like C#, C++, or any other executables or batch files for that matter, and you want to run that once the role starts, and that is where the setting is, role entry point. It is a new settings which was added in Windows Azure SDK 1.5, I think. Yeah. And once that role entry point exe which we have given access to, and if it stops, your role also automatically restarts. That is how you define your custom role entry point. So here in your service definition file, you have, for example, in worker role, I have runtime execution context as limited, and that's where I say entry point. An entry point, I can say my program entry point is command line my process.exe. Set ready on process start true. It means once the process starts, set the status saying that it's ready, and the worker role is going to be ready for that matter. There is another type of role entry point where you can execute an assembly. You can just run an assembly with a specific interface which Azure has provided, and you can make use of that as NFX entry point. Yeah. But for most of the purpose, like if you want to keep running some of the EXEs and you want that to be done through a program entry point, this is the way to do it. Okay. Now, after talking about, I think we are covering small topics, but they are very important in the advanced scenarios. We are going to see them one by one in our Visual Studio demo. Before I go to the next topic, I just want to touch base on the topics which we have seen. We have talked about default domains, upgrade domains. We talked about Starup Tasks. We talked about role entry point. We talked about local storage, and now we're going to talk about role environment communication. So if I have multiple roles in my system, in my Windows Azure project, I could have like web role, worker role, I could have two worker role, one web role, that kind of scenarios. So how do they communicate? There are two ways to establish that communication. One is a synchronous communication, which can be done through an internal endpoints. So internal endpoints are direct communication, or it is like you have an internal endpoint available to only those roles. They are not available from the outside. To make use of internal endpoint, these applications, these roles should be part of the same application deployed to the cloud. For example, I can have one cloud project or package which includes two roles like web role and worker role. If I make use of internal endpoint and I deploy them in the same package, then and then I can make use of this internal endpoint. Otherwise, I cannot communicate to them. It is a channel-based communication, so you can use service host to communicate on internal endpoints. You can use TCP endpoints, for that matter, to communicate with other role. Control the communications, and if you want to control how multiple roles are going to communicate, what kind of rules you want to set up, you can do that in your network traffic rules setting in service configuration, service definition file. We'll see that. There are a few scenarios which I have just tried to read from MSDN. Like scenario 1, web role talks to worker role using direct internal synchronous communication. In scenario 2, web role talks to two separate worker roles independently. Scenario 3, web role talks to one worker role 1 and worker role 1 talks to worker role 2. So these kind of rules you can set up using the network traffic rules in your service definition file. Synchronous communications are, you have to be very careful about using it, because it is as good as if you send a request from web role to worker role, your web role is still waiting that process to complete and till the worker role comes back with some response. And in case at times synchronous communication is not the best way to implement decoupled systems, long-running processes, etc. So for that we have queue, where we'll just see what is Windows Azure queues quickly, and we'll see how we can make use of it for establishing asynchronous communication between web role and worker or multiple roles for that matter. So Windows Azure storage actually ensures that a message can be processed at least once, and you can put messages in the queue. You can get messages. Once you get a message out of the queue, it is invisible for some time so that nobody else can access the same message, and you can set your specific invisibility timeout for that. You can delete the message once it is done, so that it is never, it is like you completed the process. In case if the worker which is working on that message, if it crashes, the message becomes visible so that it is available for the next processing, and that is the problem with the synchronous communication, right? So if you send a message to worker role on internal endpoint, and if worker role is down, your web role is infinitely waiting for that response, which does not happen when we use queues, and that is why I thought of touching base on what is queue. Using queues, you can make use of, you can implement your asynchronous communication. It enables workflow between multiple roles, and you can see in the diagram. So web roles are putting messages in the queue, and the same queue is being accessed by multiple instances of the worker role. Multiple instances of the worker role. So you distribute your load. At the same time, there is a high availability because queue message guarantees message at least once, processing message at least once. So you take a message, this worker role instance is working on that. Another next instance will take the next message, and they'll keep doing that kind of thing. If worker role crashes, so the message will reappear in the queue, because you have to explicitly delete the message before once you complete the processing on that message. And this is the best practices of implementing asynchronous communication, and that is why we generally suggest and prefer to use queue-based communication in multiple roles rather than using internal endpoints. So load work is generally set up in the queue, and producer can forget about messages once it is in the queue because it is asynchronous communication. Many workers consume the same queue, so you can distribute that load of putting the messages. For example, if you think in the queue you are getting like 10,000, 1 million messages, you can spin up multiple instances of worker role. So it's a standard advantage of loosely coupled systems. You can read messages in batches. Now, not necessary to read one message at a time. If you want, you can set up the parameters saying that I want to read 100 messages, I want to read 50 messages, and those kind of things, and multiple worker items per message. You can also include multiple execution tasks in one message. I mean, it depends on how do you configure your message. So having seen this, we'll come back to this presentation, and now let us go back to our demo, and we're going to touch base all the concepts which we just discussed. Okay, so I'm going back to Visual Studio. So to explain this concept, we have a demo available on Windows Azure platform kit called as guest role, and I'm going to make use of that with slight changes in that. So before I run this demo, let us talk about a few concepts which we learned in this presentation. So we talked about events and methods available on the role entry point. So look at it. If I have web role here, so in this solution I have web role, one worker role, and they are packaged in the same cloud project, so that I can make use of them in a single package. So for the web role, I just tried to put some code so that we understand where do we write code for our methods. So onStart is by default provided once you start a new project. OnStop is something which you have to explicitly override and write in your code. So this is a method which gets called when the role is stopped. If you want to trap few events like role environment changing, you can add an event handler to that. Role event stopping, you can add another role. You can add your role event handler to that, and that is where you are going to write the code before some graceful exit of your application before stopping it. In terms of changing, so you have this role environment changing event where you can keep. We have seen that code. Like if I want to just trap the topology changes, I can see that using link saying that role environment.curl role instance, and I can get the if the change is of type topology change, it means my instances has changed. I can do that. If I want to just don't restart it, I can say e cancel equals to true, and it will actually restart my role. So that kind of code you can write in your web role file here once you start the project. That is about events and methods which are available on role lifecycle. We'll see other concepts also, but before I go through those concepts, let's run this. So this solution has two roles. One is a web role, one is a worker role. So web role is, and we are using queues here for asynchronous communication for the processing, and I just run this project on the local environment. So the idea here is, how do we establish communication between multiple roles? And here we are using queues to establish that communication. So in the web role, I have an user interface where I can upload a file, an image file, and I can large files I can upload, and I pass that task of converting that image file into thumbnail to worker role, and worker role converts that large image files into a thumbnail, and it sends back and updates the table storage from where the web role is going to read whether I get a new thumbnail or not. If we do it synchronously, so what would happen is web role will keep waiting for that thumb image, the bitmap, the new bitmap. Till the time the new bitmap gets created, web role has to wait, and that is what we don't want. So let us see. The name is demo2. I say hi from demo2, and I'm going to upload a file here. Well, I'll upload a large file on here, and I say modified. Now you see my web role is respondent here. Okay, I'm not waiting for a response to come back because it is a asynchronous communication, and this web role will keep. It has a timer behind it just to check the database if I got a new value of the thumbnail or not. You see this? I got the earlier image got converted to thumbnail, and this conversion has been done by worker role, and it put it into the database Azure storage table from where I'm actually web role is making use of these thumbnails. You see this? So this is an example of asynchronous communication. This project is available under Windows Azure hands-on labs or platform kit, and we are using the same project for explaining the concepts. So this is the idea. Now let us drill down to this application and see how we can make how we are writing code, how we are accessing queues, how we are accessing blobs, those kind of things. Okay, so I stop this application. Now to begin with, let's go to web role, and I have here my default page. So when I upload the file, okay, so what I'm doing here is I'm just uploading that file into the blob container, and then I'm adding a message in the queue. If you see here in the queue storage, I'm getting a guest thumbs as a queue, and I'm adding a message saying that the message will have the blob name, the partition key, and role key, from where it is going to get that blob, update that entry into the table storage. We'll see that one by one. And in the worker role, so the idea here is web role is just getting the file uploaded to blob as a large file and adding a message in the queue saying that I got a large file, please process it. Please convert it into bitmap. Please convert it into thumbnail image. And worker role, there is no direct communication. Web role doesn't have to wait for worker role to complete the process. In the worker role, we are just in the while loop, in the run method, which is infinitely running. We are just reading the message. We're just reading the queue and seeing if I get a message. If I get a message, I break that message and understand where the file is. And I run my method called as converting that into thumbnail blob, and I upload back it to the blob and update the table, saying that I updated the thumbnail, and now you can pick it up from the table storage and blob storage. And that is the process. The best example of splitting the task between two things like web role and worker role using queues. Just to make it more clear, I am going to put a sleep here for worker role so that we can see the messages in the queue, and I'm going to use, anyways we are using development storage here, so we can see using our friend Azure Storage Explorer where are those entries being stored. So here the guestbook entry is a table storage for the data structure, and here you can see the messages which I have put here. So I have two URLs, the photo URL which is being uploaded to the blob, I have that URL, and I have thumbnail URL. So worker role just updates this record, and if you have the thumbnail URL ready, it will put it into blob and update this table entry, and from where web role is actually reading it. All the blobs, guestbook pics are stored here. These are the images. If I want to open it in the table storage, I can see those images being stored here. And this is a large image which I had uploaded here. For the same image, I have a thumbnail which is being created by worker role, and it's uploaded to blob, and table storage table entry has been updated. We make use of queue. The queue name is guest thumbs, and as of now you would not see any message because every message has been processed. And just to make use of those, what we are doing here is we are just asking our worker role to sleep for 1 minute so that we can see some messages in the queue. So I run it once again. Now this time the worker role will not process messages immediately. It is going to wait for 1 minute so that we can see all the messages available in the queue. So I say demo 3, hi demo 3, I browse, upload another image, I go back demo 4, hi demo 4, and I upload another message here, jellyfish, and I say upload. Now till the time it processes, let's go to queue here using Azure Table Storage and see. So these are the two messages which we added from the web role. And if I see this message, it is nothing but a plain string, okay, which I am using some delimited values to say that this is the name of my blob, and this is the row key, partition key, where the table entry is all about. And if I go back to table, guestbook entry, I have some records for which, okay, so all these thumbnails and everything is actually being inserted in here, and I have blob. So I just, for some of the images I don't have thumb because thumb images will be created by a worker role itself. So still the messages are in the queue. So after 1 minute we should see the messages went back, and I should see here I got the images created. So that is how the queue web role and worker role work on a queue. So that was idea of this demonstration. We're going to talk about few other tasks, like if you want to develop, if you want to put an internal endpoint, for example for worker role. If I just go to worker role, say properties, you can create endpoints anywhere in web role or worker role. So when I say add endpoint, so input endpoint is actually an external endpoint. Just bear with the name. And an internal endpoint is an internal endpoint which is available only communication between roles. It is not available for external usage. This is how you can define your endpoints, internal endpoints. And you can have the protocol like HTTP or TCP. So generally we had used TCP endpoints in worker role, which communicates with web role. You can add the endpoints here, and you can make use of service channel, service host of WCF to communicate between them. Second thing about local storage. Let us talk about local storage now. Now, just imagine when I am creating these images, okay, I just want to keep them in my local storage for temporary availability in a temp folder. In case if there's something goes wrong, I should be able to read it from my local storage. That is the idea, just for this demonstration purpose. So how do I define that? So here, in the worker role, I'm going to define an attribute called as local storage, which is available in a service definition file. And I just say local images, and I say clean on recycle because I know it is going to be a temporary files. So no point, no worry if we recycle this storage. I'm saying, I just need 1 GB of space for that. So this is how you define your local storage, local images. Now in the worker role, I'll show you the code where we are accessing it. Now here, the method which we are calling from conversion, like here I'm creating a thumbnail in the worker, and here I am calling this method called as save to local. I'm passing the thumbnail and the file name which I got from the blob URL, and here that is how you access your local resource. You say local resource, name of the variable, RoleEnvironment.local resource, the name of the local resource which you have given. So in the service definition, we define it like local images, and then I say thumb.save. This is like bitmap image, and I concate this with the root path. Root path is like a folder path, basic folder path of your local resource, and you just append the file name to it, and you should be able to save this. Now let us debug this, so that we know where it is, how we are going to access it, and whether it really saves the file or not. We're going to see that. In some of the cases where temporary storage, like you want to temporarily create some files, keep it on the VM, you can make use of this local storage, and that is where we are explaining the local storage here. So I said demo 5, I from demo 5, sorry 5. Okay, I append the file, I say here, and I have put the breakpoint in here, so it should come, any point it should come in here. Okay, so I forgot to took out that sleep time of 1 minute, so I will have to wait for 1 minute before it comes back in here. Now this storage emulator, I will see where we can access this, where we can see these temporary files which it is going to create when we are running it on local development environment. So you go to your this complete storage emulator, and this is the window for that. You can just click on file, you can say open Azure drive folder. It is going to give you the path where all the drive folders will be stored, but we have to go to df temp. This is the path which is being used by Azure emulator. So I go to resources, I go to directory. Okay, I think this is used by worker web role. Now I have to go to find UID, which is like directory, local images. This is the folder local images which we have. Now because every time I said clean on recycle, it was actually not storing any files in here. When I restart my worker role, it was actually creating this, clearing this. Now I say this, see this local disk, and then I have this string concate root path file name. So root path, since it is running on the local emulator, you will see some value here like local path, but when it is actually running on Azure, it is going to have a different path altogether, which is being used by Azure itself. And then I have the file name, and the moment I save it, I'm done, and I should be able to see an image here. You can see this. So this is kind of a temporary image which we have created here in the local storage, and that is how you can make use of it. Okay, 1 minute. I think I have a few questions here. Okay, now fine. So this is how you use local storage. Now another interesting part which we wanted to see about startup tasks. So I have an example here. I have VB6 sample DLL which I want to register, and imagine that I'm making use of this sample DLL into my web role. So how do you register this? So here I have added a folder to my web role so that it goes along with the package. I have added both the files, the actual DLL which I want to deploy, and I'm going to create a command file which is going to install this. So whenever I add this file, make sure to have this copy to output directory copy always, so that it is actually included in the package when you deploy it to Azure for both the files. For register.cmd also, if you go and see, it is copy always and build action is none. So that is how it is. Now in the startup task, I'll see the command. I'll show you the command file. So this is the actual command which we use to register our VB6 DLL. So I say reg sur32exe, /s for silent mode, so that it does not pop up a UI, it does not pop up a message, and my web role does not wait for some input from the user, the VM. And this is the short parameter for accessing path in DOS, %tilde-dp0, and it is going to point to startup task folder, and then I have this actual DLL name, and this is how I register my DLL. So this is my command file. How do I call this command file? So that is where we are having service definition file. So you go to startup tasks, and then you have this setting called as command line. So you say startup task / register com.cmd. This is the file name which we have just configured, and execution context is elevated because I know this registry, the register com DLL is going to take advantage of registry settings. Task type is simple because I want it to get completed first, and then the roles should start because I'm making use of those DLLs in my role, and that is why I said it task type as simple. Another interesting part here is if I just by mistake, if I don't have the correct path, and when it tries to deploy it, it is going to give us an error. So that is a good part of it. I mean, we don't have to actually keep thinking about whether this path is going to work or not. So here I have this path. So I repeat task command line, actual command line, startup folder /register com. It is here startup task register com, and I'm writing, since this is in web role, in service definition I'm creating this task under the web role. You can also make use of your environment variables, like another example, just to save on time I had already put that. So I have command line, same execution context. I want to make use of some environment variables, like so there are lots of environment variables available. You can create your own also. So this XPath variables, they are given by Windows Azure. You can make use of them. There are lists of it available on MSDN. So here what I'm trying to do here is, so I'm creating a new environment variable called as emulated, and I just want to check, if my application is running on my local machine, I should not be installing this DLL again and again, right? That is what I want to try. So here underneath this startup task, I create an environment variable called as emulated, and I set a value. I read it from XPath, role environment deployment emulated. It returns me true or false. And in my register com, I can just uncomment this and say, if this is how you access environment variable. It's nothing new, right? Yeah, I've been doing that for 10 years now, 10, 20 years, like DOS commands and all these parameters. So this is how I access my environment variable. Percentage, the name of the environment variable percentage, and I see if it is true, it means it is running in my local environment, local emulated environment, development fabric. So I just don't want to register this again and again. And I exit from the batch file. So this is an example of how you can make use of your environment variables. So and this interesting part is XPath. You can get list of this role instance value, XPath values available on MSDN. So startup tasks are done, internal endpoint done. What else? I think that's all we have today. Let us go back to our presentation and see if, okay. So before we close this presentation, I just wanted to update you on the new things which got updated in Windows Azure queues. So earlier it was possible to have only 8 KB of message in a queue. Now they have increased the size, and now you can add 64 kilobytes of message, like the strings. You have your worker role can treat your invisibility timer. Earlier it was by default set by the Azure, like it was I think 5 minutes maximum, but now you can set it to like saying that I want to make this message invisible for 1 hour, so that your processing is taking 1 hour, that kind of thing. You can set it explicitly now before when you actually retrieve the message from the queue, and you can keep renewing that queue message. For example, if you took out a message and said it should be invisible for 5 minutes, and in the process while the worker role is processing that message, you figure out that 5 minutes are not enough. You can go back and release that renew that lease, so that you can extend it by 5 more minutes, so that nobody else, no other instance of the worker role sees that message and start processing on it. You can also update the queue messages, which was not possible earlier, and it is very efficient way of continuing a worker failure. Now imagine in a process, if you read a message and there are 10 processes which you are going to execute in the worker role on that same message, like 10 steps. Now, at the end of every step, what you can do is you can go and update that message. So you completed step first, step second, step third, step fourth, and the worker role died. So the next time then another worker instance is going to take that queue message, it will start from the 5th stage because the message contains that information, that state. You can make use of that queue update message functionality in here. Another interesting part is to schedule work at future time. I mean, you can add a message and say that it should appear only on Tuesday at this time, so that you can kind of make use of this for scheduling your work, which was not possible earlier. I have a quick example of this. So you have web role is putting all the messages in the queue. Current time is 7, so I got this worker role got a message from 5-minute visibility timeout. So now this message should reappear at 7:05. This guy is processing, so it extended the timeout, and now it says it should appear at 7:09. It's keeping just updating the worker message so that 2 tasks get updated. So next time the message is going to appear is at 7:09, and it updated the message here in here. Now at 7:09, you imagine that this worker role failed. Somehow it got crashed. So the next time when worker role another instance takes up the message at the 7:09, when it is going to reappear on the queue, it has these 2 states maintained in the message so that it can start from the 3rd stage. And that is the beauty of this update message, schedule message, and distributing the tasks. That's all for the day. So I'm done. So a few other references like WindowsAzure.com is the best reference. You can just make use of pricing calculator. You can visit us on aditi.com. We have been blogging about Windows Azure, its capabilities at high level, business level, and technical level. How do you make use of these things? You can contact me on my personal email address if you want. That is there, and I tweet at Sachin San. So now let us go back to questions. Okay. So there are a few questions in here, and I'm going to pick one of them. So the one question which we have is when we use foreground background during startup. Okay. Now, in some of the cases, there are some processes which are not directly dependent on your web role or any role. Okay? For example, if you take foreground process, okay, and if there is something wrong and it shuts it down. I mean, just to answer that question, I would take you back to the startup task so that we understand the difference. Now, here it is. So here we say foreground. It is both are these asynchronous processes, and foreground will block shutdown. So if the VM role has to restart, unless the foreground process is complete, it will not restart. And that is the key to decide which one to use. In most of the scenario, like more than 80% of times, we end up using simple, because what we want is we want to complete our installation first and then start the web role or any role for that matter. So there are a few questions. How do I configure diagnostics when many websites are on the same Azure web role? Yeah, I mean, we had discussed this. This question is asked by Bharat Reddy, and we had discussed this in the previous session, how to do the configuration settings, diagnostic settings. Now, if you look at it, if you are running multiple websites, like multiple websites on the same web role, so you have host header, which is actually helping you to decide, which one is separate from where you are getting the request. And you can log that also in your diagnostics along with your log, so that you understand which one is logging it. I mean, just for tracing purpose. How do I configure the local and languages of Azure web role? Goel Vishal. So you don't have to do anything specific for that. It is as good as a Windows Server 2008 R2 available to you. You have to handle this localization and internationalization in your application code using resource file or whatever way you prefer. And that is how you actually make use of these languages and other stuff. That's all. I think we don't have much of the questions. Anything else? If not, over to moderator. Thank you. I hope you enjoyed the session, and as it was like little deeper than previous earlier session, so we thought of touch basing most of the new concepts and few things which will be very useful when we develop applications in Windows Azure. Like we touched on all the most of the important things, and we also saw a demo which is running on emulator. I mean, we could have done that, deployed that to Windows Azure, but just out of time interest, I just thought of not doing that. Thanks a lot, and see you again. Over to the moderator.
Thanks, Mr. Sachin, for your informative session on Windows Azure hands-on advanced role scenarios. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. The next session in Cloud Computing webinar series is happening Thursday, 2nd February 2012 at 3 p.m. Topic for the webinar will be Cloud Implementation Scenarios for Enterprise. We will be having Mr. Sankar Verma, Practice Manager at Yash Technologies, as our guest speaker. So see you all on Thursday. Have a nice day. Thank you.